Thanks everybody for coming out. I know it's probably been a long day for everybody, and hopefully this will be a useful hour for you before you go off and play at Replay. My name is Bob Kinney. I am a developer with the API Gateway team, and today we're going to be talking about a little bit about how to operate your production API in a serverless environment. So I'll first on the top just do a really brief walkthrough through API Gateway and Lambda. I'm sure everybody in here already has seen this multiple times, but just to make sure that we're all on the same page. Then we'll jump into monitoring your API using CloudWatch metrics, alarms, and logs. Then we'll talk a little bit about how you can protect your API with API Gateway's built-in throttling authorization, as well as the usage plan features that we launched earlier this year. And then finally, we'll talk a little bit about some of the ways that you can manage your API deployments and the API lifecycle management. So API Gateway is the product I happen to work on. So the value proposition here is that you can create a unified REST API for legacy systems, as well as microservices that you might be running with either ECS or Lambda. We have built-in DDoS protection, and as well as throttling for your backend. So that means that if you have a legacy system that you want to expose to customers, you can put it behind API Gateway, and we can offer some protection for you there. Additionally, we can do authorization and authentication for those APIs, as well as throttle, meter, and monetize your APIs through the usage plans feature. So, we have here sort of our architecture. So we have mobile clients, websites, or backend services that connect through the internet to the CloudFront distribution that's created for every single one of API Gateway's APIs. Then that comes into API Gateway. We have the ability to serve cached results via dedicated caching inside of the service, as well as emit metrics and logging from the service. Then downstream, you can then connect to a Lambda function for a true serverless architecture, or you can integrate with an Elastic Beanstalk, dedicated EC2 instances, or any other legacy product that you have that's a public API. Additionally, you can also integrate with any public AWS service, such as S3 or Dynamo directly. So then we also have Lambda, which is a great service that's obviously a lot of people here are familiar with. It's no infrastructure to manage, so it's a truly serverless offering where basically you write your code, you deploy it, and it runs based on events. And one of the events that you can do is API Gateway invocations. It's great and cost-effective, and you can bring your own code to run inside the container. Okay, so now what I'd like to do is talk to you a little bit about my friend Doug. Doug is a typical satellite. He likes his coffee. Doug also happens to be a software developer and writes applications. And he, in his spare time, built this app he called Tamper, which is a way for him and his friends to basically rate the various coffee shops and their blends. So Doug built Tamper using Tamper backend using basically serverless components, using API Gateway, Lambda, and DynamoDB. So the first reviews that Doug got on Tamper weren't great. So you can see some selections here. So the problem is that he's having some problems with errors, but doesn't necessarily know, where they're coming from. So the first way that we're going to take a look at solving this problem is taking a look at CloudWatch metrics integration in API Gateway. So by default, API Gateway offers a set of default metrics. You can see them listed here. So they include things like the overall count of the API calls, as well as the number of 4xx and 5xx error codes that your API is generating, as well as two different latency metrics, one which is the latency metric of the overall call. So that's how long API Gateway took from the time it was received until the time the request was sent out, as well as the integration latency, which is the time that it took for API Gateway to call your backend integration and get a response from the integration. Additionally, if you're using the cache feature, we also have cache hit and cache miscounts. So on top of the basic, basic metrics for the overall API, you can also get detailed level metrics. And these detailed level metrics can be enabled on a per method basis. So you can get the same set of metrics for each one of your methods. Just to reiterate, the default metrics are included for free. You get them by default anytime you actually build an API using API Gateway, and they're broken down by the API stage. If you opt in to using detailed metrics, standard CloudWatch pricing does apply there, so every one of your metrics that's tracked for your methods will be billed as a custom CloudWatch metric. So once you have your metrics, you can obviously integrate alarms with those. So then CloudWatch has obviously an alarm system that you can tie to any metric that's being generated by the system. The alarm notifications can then be sent to an SNS topic, and that SNS topic can then have subscriptions to email, SMS, or or even to a Lambda function if you wanted to double down on your serverless architecture. I'm sure probably a lot of you have already seen all of this, but I do want to highlight a couple of new things in this area that we actually just launched right before reInvent, which is that now the error and catch metrics are actually support averages. So previously you could only see a sum of your errors, your 4xx or 5xx errors. Now you can get an average. So that means that you can alarm on the rate of your failures, not just the raw count. So now what I'd like to do is switch over and do a short demo using the detail metrics and alarming. Hitting the right button. Which button was it that I was supposed to push? Oh, sorry, thank you. Okay, sorry for that short malfunction. Okay, so now what I have here is a very simple, very simple REST API built inside of API Gateway. And what I'm going to do is actually modify the settings for one of my methods so that I can start recording detailed metrics. So I'm actually going to be calling this Gatling random method. I'm going to override the settings for this specific method and enable, enable detailed CloudWatch metrics. I'm then going to go ahead and save those changes. That does not require redeployment, but I'll just wait a little while so that those settings can propagate. And then I'll bring up our Gatling run here, which is basically going to run invocations of that specific REST URL from basically 10 different users, and just repeat that over and over again. Oops, don't want Firefox. So then I'll just also highlight here real quickly our function, which is the reInvent errors function, which basically generates a random amount of errors. I'm going to set this back to small levels and go ahead and start our Gatling run. So we'll start to see here is a summary of the number of errors and OKs that we're getting from our API. You can already see that we already got 1,500 from our API for a small number of requests. So now if I switch over to the CloudWatch console and go to our brand new metrics dashboard and go to API Gateway, I'll first go ahead and look at the overall API level metrics, because our detail metrics haven't quite shown up in the CloudWatch dashboard. So you can see here that I'm already starting to get some amount of data that's probably from a previous test I was doing. And we can see on tighter periods, eventually we'll start to see a number of errors. Okay, here we go. So now we saw the last data point, and we're getting a small percentage of errors. So from here, I can Let's go ahead and see if we've got our detailed metrics coming up yet. All right, so our by method metrics are here. So let's take a look at those 5xx's. That should basically be the same. We'll go ahead and move this guy. Okay, so now from here I can see my, my detailed metrics for this particular method. I can see that I'm getting a small number of errors. From this dashboard, I can quickly create a new alarm. And then I'm going to go ahead and set this to fire at 10% or 0.1 on an average for any given period. I'm going to set it to send to a special distribution list and go ahead and create that alarm. Now I'll go back to Lambda and quickly change the parameters so that it'll actually fire. So we should now see about a 20% error rate. If I switch back to my Gatling console, I should immediately start to see a larger number of errors. You can see from that, the last run we got 20 to 50, and we're getting more and more errors coming up. And then if we once again switch back to the CloudWatch console, we should eventually start seeing a higher percentage of errors. Perils of live demos. Okay, so we should eventually start seeing an increase in the metrics, and so that will eventually cause our CloudWatch alarm to fire, which should generate an email to my account to let me know that I am in fact seeing a larger number of errors for this particular method. And so we can already see here that we've got a data point above, so this alarm should switch its state shortly. Any minute now. Okay, so our last data point here is still not quite high enough. Okay, well, looks like, oh, here we go. All right, so we did get our email, even though the dashboard didn't want to quite show us to it. So now we've got a system for finding out when these errors are occurring and in what method they are occurring in by using our detailed metrics. So our friend Doug now has set up his alarms and metrics, and he knows that he knows when these errors are occurring and with what method they're occurring, but he doesn't know why they're occurring. And that's where CloudWatch Logs comes into play. So CloudWatch Logs is integrated actually in both services, both API Gateway and Lambda. The API Gateway integration, we basically have two levels of logging, error and info. We also support full method and request response logging as well. You can set that globally on an API stage, and just as with the API or the detailed level metrics, you can also opt to do this only for specific methods. Lambda logging, you actually can provide your own logging statements. So inside of your code, you log whatever it is that you're interested in, and it will end up in your log streams for your Lambda functions. Additionally, so CloudWatch Logs has always kind of supported this idea of being able to create search filters and generate metrics from your logs. And then you can also then set up alarms on those filtered metrics and pivot back to the actual log data that generated the spike in the data that you were looking at. So anybody who's used CloudWatch Logs and Lambda and API Gateway is probably very familiar with these screens. There's just a lot of log streams. This is due to the way that CloudWatch Logs is implemented in both of the services, and it's an unfortunate side effect. So one of our developers on the API Gateway team took it upon himself to write this nice little tool that is really great for doing streaming of your logs for debugging purposes. So the real nice benefit here is that you can actually see both your API Gateway logs and your Lambda logs in the same screen. So what I'd like to do now is actually demonstrate the use of that tool. So I already have it installed on my laptop, but it's just a Python function that's available via pip. So you can just do a pip install of API logs, and you can get started using this tool. So I'm actually going to use it in the watch mode, which allows me to basically stream the contents of my API's logs as they come in. So it will watch all of the log streams to look for new data, and then we'll display it on the screen with some syntax highlighting to help me look at the logs while they're coming in. So I'm going to go ahead and start that up. I'm not going to see any output because I'm not actually sending any requests to my API. Well, okay, so we're going to get some old data. Okay. So we got some older data from some of the previous runs. I'm going to let this just quiesce just a little bit before I move on. So the tool also offers the ability to search backwards through logs, and it has basic syntax highlighting, as I mentioned, as well as basic search. Okay, so it looks like we are quiesced now. So now I'm going to switch over to another tool. Really? Okay. I'm going to switch over to another tool called Postman, which allows me to kind of do a simple request response with my API. And I'm going to invoke this function, which I happen to know is going to generate a 500. And what I'm going to hope to see now in my logs, again, if I didn't stop my stuff fast enough. Okay. Okay, here we go. So here's our, if I can pause this long enough to get the value. Okay, so I can see here, oh no, that was actually not the method I was looking for. I'm sorry, folks. Again, perils of live demos. So what I was expecting to see here is that if I had not kept my previous run running and I was seeing some old data, is that I would see the logs from the output of my REST API call. And that REST API call would actually indicate to me that my permissions error, the permissions on the Lambda function that I'm calling are incorrect for API Gateway to actually call it. And that is why I'm getting a 500 on the server side. So what I'm going to do now is open up another tab in my console terminal app, run a quick API call to restore those permissions. And then I'm going to go back to Postman, rerun that request, and now I can see that I'm getting a positive 200 response with the expected payload in return. So as you can see, the tool works works better when there's a smaller amount of data, so not necessarily a great tool for finding a specific log message in a live API, but while you're doing testing, again, really useful for being able to, debug errors that are happening in a test API. Okay, so let's check back in with Doug. Doug had turned on logging, and he was able to figure out that the errors that he was seeing in his API were actually due to a bug in one of the mobile app versions that he had shipped that was sending a spurious number of requests to a specific API. So that was causing basically the, the backend, his DynamoDB table, to get hit too often, causing him to exceed his provisioned throughput capacity, causing some 500s for customers who are calling his API. So Doug now needs a way to basically be able to limit the traffic coming from that method or from that device to basically be able to better serve the rest of his customers. So that's where we'll move on to the first step of protecting your API via throttling. So API Gateway actually offers 3 different levels of throttling. The first is API key level throttling via the usage plan feature. I'll talk a little bit more about that later. The method level throttling, so that's where you can actually define how much any given method can be called inside of your API. You can also set a stage level method default throttling level, and then override that on a per method basis like we did with the logging and the metrics before. And then finally, there is an account level throttling. And this one you don't have any control over, but you can request increased limits as your API grows. As with most AWS services, API Gateway actually implements all throttling via the token bucket algorithm. This basically means that there's 2 values that you're interested in, basically the burst level and the constant rate. So the burst level is the size of the bucket, so that's how many tokens can actually be in a given bucket, and the rate is how fast it refills. So again, probably most of you who have used API Gateway are already familiar with the fact that we do throttling, but a couple things that I do want to highlight that are recent changes in the way we handle throttling. So the first one is that we've reordered the throttling order. So we actually do it by now the most specific level, so that's API key, then method, then account. So that means that you can actually set levels on your API to protect yourself from being protect your API from exceeding the account level limits. Secondly, all throttled methods, regardless of why they were throttled, will no longer be built. So now I'd like to do a quick demo of using throttling at a method level. So I'm actually going to be running another Gatling simulation, and it's basically going to hit a different path in my API called Gatling throttling, very descriptive for what we're doing. And what I'm going to do is go to my API stage settings. Actually, I'm going to start the Gatling run first. And because I haven't set any default throttling limits on this method, it can be called as fast as possible. This means that it could potentially use all the way up to my account level limits, much as the case was with Doug. So now what I'll do, now that I have this running, is go back to my stage level settings for the Gatling throttle method. Again, override the stage level settings, and enable a throttling level. Now I'm just going to go ahead and throttle this way down to 1 RPS. And again, this does not, like these stage level settings don't require deployment, but they do take a little bit of time to apply. And what I should start to see, hopefully, in the next refresh of statistics is that we're now starting to see some 429 responses, which means that our throttling is working. And we can see that the number of OKs is going up much slower than the number of KOs, or 429s. So this is a really easy way to kind of to give you control over which methods are using up all of your account level throughput. So we'll go back to Doug. So Doug, now that he knows that the particular method that was being hit too often, he go ahead and set method level throttling on that method. He's been able to basically ship a new update to the API to put customers on a different REST resource so that they can call that method at the levels that they need to, and customers who are using the old buggy version will get some 429 response errors, but the rest of the app should stay active. So now that he's fixed some of the problems with his app and the reviews are starting to come back more positive, some of the local coffee shops are starting to notice that their customers are using Tamper to check in. And so they contact Doug because they're interested in selling basically promotions through the application to build brand loyalty. So Doug needs a way to basically be able to give these customers privileged accounts that can modify resources inside of the Tamper app and sell resources, but also protect the rest of the service. So this is where we'll start talking about authorization and authentication in API Gateway. So today there are three main methods for doing authentication and authorization inside of API Gateway. The first is AWS IAM, despite its name, it does not require IAM users. It can also use roles or Cognito temporary credentials via STS or any of those other things. So that supports basically authentication and authorization via basic IAM policy and uses signature version 4 as any other AWS service would. We also have a custom authorizer, which basically allows you to write a Lambda function to separate out your authorization and authentication mechanisms from your business logic. And that, again, allows you to authenticate and authorize your API methods. What you actually return back from your authorizer is an IAM policy style document that actually defines the permissions that specific user has inside of your API. Then finally, we have our Amazon Cognito authorizer, which integrates with the Cognito Your User Pools product. It currently only supports authentication. So that means that if you want to allow you want all of your users to have access to your API, you can do that with this. And then you can use the information that's fed into your API via the context to determine what permissions that user should have inside of your application. So both the IAM and the Amazon Cognito authorizer have no additional costs whatsoever, other than the use of those services. So for IAM, obviously that's free. For Cognito, your user pools, you pay for your monthly active users. For the custom authorizer, you pay only for the authorizer invocations that you make, but we do offer a free cache. So you can cache the results of the authorizer result, and you can offload some of your costs that way. Again, these are probably some features that a lot of you are already familiar with, but I do want to highlight a couple of new features that we launched, or a couple of modifications we launched to these prior to reInvent. The first is that custom authorizers. Previously, you could only return the policy document, which described the resources that the customer had access to, as well as what we called a principal ID. Now you can pass back a context dictionary. So a JSON document inside of that can be passed into into the API gateway function and then passed on to your Lambda or to your backend, depending on your use case. So that offers some additional flexibility there. And then finally, as we did with the throttling, now no longer do we charge for unauthorized requests. So if you set up authorization on your API, you can be rest assured that spurious traffic that's not passing your authorization checks will not be charged. All right, so now I'd like to demo a couple of the authorization mechanisms. So the first one I'm going to do is the IAM authenticated request. So there's Twitch on AWS signature, and I'll send this request. And so what I want to highlight here is, so the Lambda function I'm using here is literally just passing back whatever was passed in. And I'm using the API Gateway's Lambda proxy feature, which basically passes all of the request metadata in from API Gateway to Lambda. So what I'm getting back is basically the full context of the request that's being sent to API Gateway. So a couple things to highlight here. Inside of this identity block, you can see here that we have additional information about the IAM user that I'm using here. So I can see an account ID, which is actually going to be mine, as well as a principal ID in, as well as an access key. And then I can also see the actual IAM user, because I used a user in this case, but if it was a role, you would see the role information as well. Okay, so now I'll switch over to the custom authorizer, but first, let me switch back to the AWS console and just take you through the authorizer code really quickly. So this authorizer is based on the existing blueprint that we have inside of Lambda. It is modified to use the new context values. The blueprint hasn't been updated for that quite yet. But you can see down here at the bottom, basically, it's a really dumb check, but it's a useful example. If I pass in the value allow as a token, I will be allowed to call this method. If I pass in the super value, I get to do an additional amount of privileges. I'm additionally passing back some context about this user. So the normal user is me. The super user also happens to be me. That's my legal name. So then if I go back over to Postman and I see that I have the allow method and I do send, if I go down to the authorizers portion of the response body, down here, so you can see here that we have the authorizer. I have my principal ID, which is the normal user, but additionally, all those context values get passed in as keys into this map. So those are all available to me inside of my Lambda function. If I try to call a method that I am not allowed to call, I get an appropriate error message saying that I don't have access to this resource. But then if I change it, if I change my headers to that super user, the super user is allowed to access this method. And again, if I scroll down to the authorizer, I can see that the principal ID is changed, and now that I can see the context for that user instead. So for the custom authorizers, you'll also note that none of the identity information down here is filled in. So this is specific to IAM identities. The authorizers will be filled in for both the custom authorizer and the Cognito authorizer. Okay, so Doug set up his promotions interface and used custom authorizers to set it all up so that the users could access and modify and create promotions, and it's been a big hit. Now Doug has been talking to some other services that are interested in doing partnerships. So there's an app that does reviews for brunch locations. And so they're interested in using, partnering with Tamper to be able to offer the reviews of the coffee at those brunch spots. So Doug wants a way so that he can expose his APIs to third parties like this brunch app, but also be able to track and limit their access to call his API so that he can potentially monetize it later. So that's where we'll jump into our last topic on protecting your API, which is usage plans. So usage plans is a set of features that we launched earlier this year in, I believe, April. That allows you to do controls both of throttling and quota, so a periodic quota, by API key. So API keys were available when we launched, but basically they were only available to kind of just do really basic authorization checks, so whether or not you had a key or not. With the launch of usage plans, you can now track to see how often an API key is being used on a daily basis via our usage metrics, and as well as limit those calls with throttling and quota so that you could then build usage reports and bill directly through to the customer. I will note that the AWS SaaS marketplace actually uses this information, so that's actually how that integration works. So if you're interested in reselling your API through the SaaS marketplace, you would be using usage plans. So now I'll quickly demonstrate the use of usage plans for throttling and quota. So I'm going to switch back to using Gatling again. And so I've pre-created a number of keys and an associated usage plan, and I'm just going to call this usage plans method, which is actually enabled for keys, with all of these keys in parallel. So quickly, I'm just going to go back to the API Gateway console and show you the usage plan. So I actually have 3 different plans. Two of the keys are actually under this quota plan, but I have a high-level throttling limit, which allows for 1,000 RPS for the key with no quota. I have a low throttle rate with 1 RPS with no quota, and then our quota usage plan allows 2 RPS, but limits the request to 50 requests per day. So I'm going to go ahead and start up my Gatling run for this. So you can see here already that we've got key 0 is our high-level key, so that's getting through no problem, no KOs, everything's going through fine. Our key 1 is our low-level throttling, so there's only about a request a second going through that key, and everything else is being sent to 429. And then our 2 bottom ones, key 2 and key 3, are set on our quota. So you can see now that they've hit their 50 calls per day limit, and they're basically not generating any more OKs. They've capped at their limit. So if you're using usage plans and you have a customer who has hit their quota limit, we actually also offer the ability to extend the quota for the period that they're in. So we support daily, weekly, and monthly quotas, and so you can give a customer an extension for the given period. So I'm going to go ahead and give key 2 another 50 requests for today, so we can see that hopefully. And so what I should see, again, once the configuration propagates, is that key 2 will start to be able to then, at 2 requests a second, start to be able to see some OKs again, and eventually will hit 100 requests, at which point it will have hit its quota again, and the customer can either request another limit increase or wait for the next period. So again, we're creeping up on 100 requests. And again, our other key has stayed at 50. And once again, we hit 100 and everything's back to where it was before. Again, all of these requests that are KO'd, again, no charge whatsoever. So if you have a customer who's that you need to turn off for any reason, you can just simply turn their quota or their throttling rate to 0 and not have to worry about them causing your bill to go up. So now Doug's gotten these partnerships. Everything's continuing to grow. He's actually making enough money from Tamper that he's actually able to bring on some other people to help work on the application. So he's looking for ways to formalize his update process now that it's not just him that's making the updates to the API, but a number of developers working for him. So now let's talk a little bit about some of the ways that you can manage your API with API Gateway. So the first way is with API stages. So API stages are the way for a named link from a deployment of your API to a name. So you can create a deployment that is not associated with a stage and then associate the stage to it. You can also quickly do rollbacks this way. And it's a great way for you to do for managing API lifecycle. So dev test, prod, or alpha, beta, gamma, depending on which terminology you use. It additionally supports parameterized values, so via stage variables. So this could be things like your beta API hits a beta database, so that uses either different credentials or a different RDS database, for instance. You could put that information in your stage variables and then control, keep the same code, but just but parameterize your actual values inside of the API. Additionally, on the Lambda side, we have support for versioning and aliases. So this is a great way to deploy updates to your Lambda code and then also move the aliases much in the same way that you move the stage aliases. These work really great with stage variables. So you basically set up your stage variables to point to a specific alias. And then when you're versioning your Lambda functions, you can just move the Lambda function alias from one version to another. Additionally, API Gateway supports custom domains. So this is a great way for you to either brand your API as well as offer multiple versions of your API. So this is one of our recommended methods for versioning. You actually have your API. So in Doug's case, we have api.tamper.com/v1 goes to his v1 version of his API. And api.tamper.com/v2 goes to a different version of his API, which was cloned from the existing API. Additionally, API Gateway supports Swagger import and export. So Swagger is a portable API definition that supports both JSON and YAML. As I mentioned, you can import and export. So this is a nice way to be able to source control your API definition. So you can run code reviews and push your API up to API Gateway after it's been reviewed. Additionally, you can also do merge imports. So if you have teams that are working on disparate portions of your API, you can have them work on a subset of the Swagger document and only import that portion as a merge import and update that portion. Deployment mechanisms. So this is an evolving space, to put it mildly. Up here, I have listed a few different methods for managing deployments. The first is Chalice, which is a Python micro framework, which actually offers a little bit more than just deployment management. It also integrates with various Python web service frameworks like Flask, and includes deployment scripts for managing the lifecycle. This is actually written by one of our developers on the Python team, so it's maintained by AWS. Next, we have serverless, which used to be formerly known as JAWS, which is a great, a great framework which actually offers, has started working on cross-platform support for serverless architectures, and it supports Node.js, Python, Java, and Scala. And it allows you to describe the API resources as well as the API description. And then finally, the serverless application model, or SAM for short, which some of you may have seen earlier today, which is our extension to CloudFormation to basically smooth out some of the edges and allow you to describe more of the resources in your API and not just the API definition. Okay, so hopefully this was useful, and I want to send you away with the message that to be like Doug. So we'd like you to monitor your APIs with CloudWatch metrics and CloudWatch logs. We'd love you to use the throttling and authentication mechanisms to protect your API. We'd love you to use usage plans to make your APIs available to third parties and make your APIs grow even larger, as well as manage your API with one of the available tools for deployments and lifecycle management. So that's actually the end of our talk today. Unfortunately, actually, I have this up here as visit the booth, but the booth I don't think will be open tomorrow. So if you do have any other questions, I'll be around here for a little while before heading over to replay myself. So I'll be happy to answer questions. If I can't answer your question here, feel free to reach out to us via the forums or on Stack Overflow. AWS engineers actually monitor Stack Overflow tags and answer questions there as well. Excuse me. And just as a final note, thank you. Do please make sure to complete your evaluation forms. It's extremely useful for me as a presenter, as well as us for a company, to make sure that we're generating content that is useful for you. And with that, thank you very much and enjoy replay.